Hi there, this is Seth Schaefer from Team Just Cause Robotics, and in today's video, I'll be discussing the start of a new project of mine to make a super fast brushless plastic antweight robot. I have a number of reasons for pursuing this as my next project. Firstly, I wanted to build something cheap and that I can safely test outside my test box. Second, I've already made a number of spinner bots, but I feel it's about time I work on a control style bot again. Third, I've seen a multitude of antweights that use the same electronics in the 150 gram and 1 pound classes, but I want to do something different by taking another direction. I think it should be possible to make a really fast and powerful drivetrain using the same $5 motors I'm now using with Division, and without the metal gears it should be possible to keep it light enough for about the third of the weight. My goal is to use much larger 3D printed plastic gears running on metal shafts in order to keep the weight down and still get a robust and powerful 4-wheel drive system capable of pushing other bots around. And to do this, I can only use PLA, PETG, or ABS as specified in the Plastic Antweight rules. Quick aside. With the announcement of BattleBots Season 5 filming in October, I'll soon need to shift to working more on Bloodsport over the weekends leading up to it. Obviously, I'll be making videos about that progress as well, so stay tuned for more on that front. I'm planning on competing alongside Justin and the rest of the team at the tournament, so I'm excited to be involved on the televised show for the first time, as I joined the team months after the 2019 competition was filmed. I'm going to be filming another weapons test sometime soon, card above to the last one. And this time, we should be using the thick bar and all 4 weapon motors with an even higher current limit to boot. Make sure to subscribe if that's something you want to see. Now back to the antweight. A typical 1 pound, 454 gram US ant like a Viper kit might use silver spark motors and tiny ESCs. These are $18 and $26 respectively, meaning 2 drive sides will cost about $88 US plus shipping. Furthermore, the silver spark motors weigh 28 grams, which is 10 grams heavier than the 1806 motors I'm running in my new brushless Beetle gearboxes. Silver spark motors are far from ideal, but they are very compact and are used by many as such. By comparison, the $5 DYS 1806 motors and $10 BL Heli ESCs I'll be using should cut down on weight while increasing the allowable power output more than 6-fold, even at 2S. The catch is that the motors used in silver sparks have a gearbox fitted, making up all that extra weight, and the motors themselves are under 1600 kV. The least gearing sold on Fingertech's website is 11:1, meaning that the motor RPM of about 12,000 becomes a much more usable 1050 RPM. Brushless 2300 kV motors at 2S will be around 17,000 RPM, and with only FDM printed gears, I can really only get about a 2:1 ratio in one stage, so my ant will have an absurd top speed of over 20 miles an hour, but it should still have enough pushing power to move itself and an opponent bot. Now, this concept of using an oversized brushless motor and 3D printed gears is not new. In fact, the very well-known Beetle Smee does just this with 3D printed nylon gears and an oversized brushless motor to drive a pair of big printed wheels. Where my design would differ is that I have a third of the weight and I'm limited to using the less ideal materials that may be used for the plastic ant class, PLA, ABS, and PETG. Right now, I'm in the very early stages of the design, so this video is just to explain what I'm going for and what I've thus far accomplished. I currently have a working prototype of a drive pod with a 2:1 ratio. The design of this drivetrain was actually a lot more difficult than I thought it would be, as the motor itself has a 4mm prop adapter which set the smallest gear diameter that I could use. Because the motor is so fast, I needed the smallest wheels possible, but the larger the wheel, the larger the mating gear, and then the larger the ratio I could achieve. Using my drivetrain calculator, see card for related video, I was able to determine that the ideal balancing point between bigger wheels needing more torque and bigger gears providing it was at 0.82 inch diameter wheels with a 2:1 ratio in order to push 2 pounds. As far as other parts go, I know I want this to be a control bot, but what exactly I use for a weapon is still to be determined. I'm planning to use these little 2S 300 mAh Lipo batteries because they're some of the smallest available on Amazon and can deliver the high burst current these motors need, and they should allow the chassis to be fairly short. I'm going to use the same small FS2A receiver I used in Minimulture for now because I have them on hand and they'll handle 2S without a BEC. This means I won't need anything at 5 volts in the whole robot. I'll probably begin by designing a servo lifter weapon, but that's pretty overdone, so I might switch to something more interesting later. Links to all these components will be in the description down below. I want this to be a bot anyone else could fairly easily replicate, as that's the spirit of the plastic ant class. Anyone with a 3D printer and some know-how should be able to do this too. If you have any suggestions for a 3D printable non-spinning weapon, leave a comment. I'm open to suggestions, as long as it won't be too heavy, complicated, or expensive. That's all I have for you today. If you liked this video, leave a like. If you have questions or suggestions, leave a comment. And if you want to see some more content like this, or more about BattleBots, subscribe. Thanks for watching.